Hey there! Stack Lessons here. Today's drill is 20 questions on provisioned throughput and serving tiers, RAG architecture and vector scale, and AI gateway guardrails. You know the format: question, countdown, reveal, explanation. 10 seconds is the default, but pause anytime. Let's get started. Here we go. Let's check question 1. Quick check. A generative AI engineer at Aldgate Capital is logging a fine-tuned model checkpoint using MLflow.log_artifact. The checkpoint file is 4.8 GB. A team member raises a concern that the file may exceed the platform limit. What is the per artifact file size limit for MLflow uploads and downloads? Select 1. Review the answer choices on screen. The correct answer is option A. 5 GB per artifact, the platform ceiling. MLflow enforces a 5 GB per artifact file upload and download limit. A 4.8 GB checkpoint file falls within this limit and can be logged without issue. The 100 MB and 1 GB values significantly understate the actual platform limit and would incorrectly block large model artifacts that are fully within the supported range. While MLflow routes artifact storage to DBFS, Unity Catalog Volumes, or S3 compatible object storage, it still enforces a file size ceiling of 5 GB per artifact, rather than allowing unlimited uploads to those backends. Now, question 2. The wrong answers are close. A generative AI engineer has deployed a foundation model API endpoint on Databricks for a high-traffic internal Q&A tool. During peak hours, requests queue because the endpoint is processing at maximum current capacity. The engineer needs to guarantee a baseline processing rate at all times and allow the endpoint to scale automatically during traffic spikes. Which two parameters should they configure on the provisioned throughput endpoint? Select 2. Review the answer choices on screen. The correct answers are option A and option C. The RRF param and temperature answers look very plausible. Provisioned throughput endpoints require both a minimum and maximum throughput boundary. Setting min_provisioned_throughput guarantees that the specified baseline in tokens per second is always available, preventing request queuing under typical load. Setting max_provisioned_throughput defines the auto-scaling ceiling, allowing the endpoint to handle traffic spikes up to a defined capacity limit without incurring unbounded cost growth. The sampling_fraction parameter controls what fraction of requests are captured in inference tables for monitoring, and has no effect on request processing capacity. The RRF_param is an AI search configuration for tuning reciprocal rank fusion in hybrid search, and is entirely unrelated to model serving throughput. Temperature influences the probability distribution of generated tokens, and does not affect how many requests the endpoint can process per second. Now, question 3. Start with what the user needs. A generative AI engineer at Viewpoint Studios is building a content policy enforcement system for user-uploaded media. Each submission may include a thumbnail image, a short video clip, or both, combined with a text description. The system must analyze all provided modalities in a single model call to detect policy violations, without requiring an additional pre-processing pipeline. Which foundation model API model should the engineer select? Select 1. Review the answer choices on screen. The correct answer is option B. Video is the decisive modality only one model handles natively. Gemini 2.5 Flash natively supports all 4 input modalities: text, image, video, and audio, within a single model call through the Foundation Model API. This native video support is the decisive differentiator that allows thumbnail images and video clips to be processed simultaneously without any additional pre-processing pipeline. Claude Sonnet 4 supports text and image inputs within the Foundation Model API, but does not support video as an input modality, making it incapable of natively ingesting video clips for policy analysis. Llama 4 Maverick similarly supports text and image inputs only, and cannot process video content without a separate frame extraction step that routes the work outside the model's native capabilities. BGE Large is an embedding model that produces vector representations for retrieval and similarity search. It cannot interpret visual or video content, cannot detect policy violations, and cannot generate structured text output of any kind. Let us keep moving. Question 4. Match the answer to the situation. A generative AI engineer is building an LLM-powered predictive maintenance assistant for a smart manufacturing company. The assistant generates repair recommendations by reasoning over real-time sensor data, current machine temperatures, defect rates per production line, and vibration anomaly scores that are updated every few seconds by IoT pipelines. Which Databricks component should the engineer use to supply these live sensor readings to the language model at inference time? Select one. Review the answer choices on screen. The correct answer is option A. Feature serving was designed exactly for this live lookup pattern. Feature serving exposes pre-computed and continuously updated values through a low-latency, auto-scaling endpoint that an application can query at inference time to ground the language model's generation in current data. In this scenario, the IoT pipelines continuously publish sensor readings that are materialized as online features, and the feature-serving endpoint delivers those readings with minimal latency to the LLM prompt. Foundation Model APIs provide access to the language model itself for generating text, but carry no machine sensor data. AI Search is a vector and keyword retrieval system for retrieving documents from a static or periodically synced index, not for fetching continuously changing numeric telemetry. Inference tables capture the requests and responses of a serving endpoint for monitoring and debugging purposes. They do not serve live data to a language model at inference time. Let us keep moving. Question 5. Use elimination aggressively. An MLOps team at a datum uses Databricks with Unity Catalog to manage registered machine learning models. A compliance officer asks the team to satisfy two audit requirements. All model promotion events must be permanently recorded with the identity of who performed them, and data scientists from a partner team must be able to review model metadata and performance metrics without being able to register new model versions or reassign production aliases. Which two Unity Catalog capabilities address these requirements? Select 2. Review the answer choices on screen. The correct answers are option C and option E. MLflow tags look auditable but carry no enforcement mechanism. Unity Catalog audit logs automatically capture all model registry operations, recording the user identity, action type, timestamp, and affected resource for every alias assignment, version registration, and lifecycle transition. This creates a tamper-resistant, identity-linked audit trail that compliance auditors can independently verify. Unity Catalog access control through grant and revoke statements enforces fine-grained permissions at the model and schema level, making it possible to give the partner team read visibility into model metadata and metrics, without granting them the ability to register versions or reassign aliases. Custom MLflow tags are applied manually and can be omitted, overwritten, or forgotten. They are not a reliable auditable record because they carry no enforcement mechanism. Delta change data feed records row-level data mutations in delta tables, but does not capture user identity in model registry governance events, and is not the appropriate audit mechanism for this purpose. Sharing Delta table history links provides data read access, but does not address the permission boundary requirement or produce a structured audit trail of model governance actions. First 5 questions established 2 key platform numbers, the 5 GB MLflow artifact ceiling, and the dual min-max provisioned throughput pattern, plus Unity Catalog's audit log and access control pairing for compliance governance. Time for another one. Question 6. The obvious answer may be bait. A knowledge management platform is building a semantic search engine over a corpus of archived enterprise documents. The corpus already contains 1.5 billion embedded vectors at 1024 dimensions, and the engineering team anticipates adding approximately 50 million new vectors per week. Query latency up to 500 milliseconds is acceptable, but sustaining high indexing throughput for continuous ingestion is the top priority. Which AI search endpoint type should the team configure? Select one. Review the answer choices on screen. The correct answer is option D. The phrase exceeding 1 billion is the threshold that changes tiers. Storage-optimized endpoints are specifically designed for corpora that exceed 1 billion vectors and provide 10 to 20 times faster indexing throughput compared to standard endpoints. The trade-off is approximately 250 milliseconds of additional query latency, which falls within the acceptable 500 milliseconds threshold the team has specified. Standard endpoints handle approximately 320 million vectors at 768 dimensions and are not rated for multi-billion vector corpora regardless of auto-scaling settings. The choice between a direct access index and a delta sync index governs who manages the embedding computation and is orthogonal to endpoint capacity tier. Neither option increases indexing throughput to the level required here. Serverless compute endpoint partitioning via delta tables is not a valid Databricks AI search configuration option. Time for another one. Here's question 7. A generative AI engineer at Northgate Systems is building a RAG application using Databricks Foundation Model APIs. The retriever returns 3 relevant document chunks in response to a user question. The engineer must pass the user's question together with the retrieved context to the LLM before generating a response. How should the retrieved context be incorporated into the LLM request? Select one. Review the answer choices on screen. The correct answer is option C. Augment means combine, one prompt, all context included. The augmentation step in a RAG pipeline assembles the retrieved context and the user's question into a structured prompt template before the single combined prompt is passed to the LLM. This gives the model all the grounding information it needs in one coherent input, enabling it to generate a response anchored in the retrieved documents. Making separate API calls per chunk prevents the model from reasoning across all retrieved information simultaneously, multiplies API cost and latency, and produces fragmented responses that must still be merged. LLM APIs accept text prompts, not file paths or table references. Passing a Unity Catalog table path would not cause the model to retrieve or interpret the table's content. Passing only the original user question without the retrieved context removes the retrieval benefit entirely and reduces the system to a standard LLM call with no knowledge augmentation. Ready. Question 8. This is a two-step filter. A generative AI engineer at Brixton AI has enabled an inference table on a customer-facing model serving endpoint. During a post-incident review, the team discovers that a subset of requests sent during a traffic spike is absent from the inference table despite the endpoint remaining operational throughout. Which two conditions can cause requests to not appear in the inference table? Select 2. Review the answer choices on screen. The correct answers are option A and option B. Two separate platform rules can each erase records silently. Two distinct conditions cause requests to be absent from inference tables. Requests that result in HTTP 429, too many requests, errors, along with 401, 403, and 500 error codes, may not be captured. These error states occur at the infrastructure boundary before or outside normal inference completion, meaning the logging pipeline may not fire for those requests. Separately, any request or response payload that exceeds 10 MB in total size is not logged at all, regardless of response status code. There is no minimum capture latency threshold. Inference tables capture requests based on status code and payload size, not execution duration, so fast requests completing under 50 milliseconds are logged normally. Concurrent reads of the inference table by other engineers do not affect the write path that logs new requests. Reads and writes to the underlying delta table are independent operations. Requests that complete successfully with HTTP 200 responses and valid payloads below the size limit are captured as expected. This one trips people up. Let's look at what inference tables actually log and what they skip. Imagine your endpoint just survived a traffic spike. You open the inference table, but 40 requests are missing. What cut them? Two things. First, any request that got a 429, that's too many requests, never makes it to the log. Same story for 401, 403, and 500. These fail before the model runs, so the logging pipeline never fires. Second, payloads bigger than 10 MB are simply skipped. One giant response body and that row disappears. What doesn't matter? Speed. A 30 millisecond request logs just fine. There's no latency flaw. Concurrent reads on the table can't touch the write path. The exam tests two hard stops: error codes and payload size. Ready. Question 9. Choose for this case, not every case. A generative AI engineer at Granville FinTech is deploying a provisioned throughput foundation model API endpoint for a trading analytics assistant. The SLA requires guaranteed minimum capacity at all times to avoid cold start delays, but traffic spikes during market open and close require the endpoint to scale beyond that baseline. Which configuration correctly implements both requirements? Select one. Review the answer choices on screen. The correct answer is option C. Minute reserves the floor. Max caps how far the endpoint scales. Provisioned throughput endpoints expose two configuration parameters for capacity management. Setting min_provisioned_throughput reserves a guaranteed baseline of model units expressed as tokens per second that remains always active, ensuring the endpoint can service requests immediately without cold start delays, and satisfying the SLA floor for guaranteed capacity. Setting max_provisioned_throughput caps the ceiling for auto-scaling, controlling cost exposure during market hour traffic spikes, while allowing the endpoint to expand capacity beyond the baseline when demand requires it. Configuring only max_provisioned_throughput without a minimum means the endpoint may scale down to very low or zero capacity during quiet periods, creating cold start latency when trading activity resumes and violating the guaranteed availability requirement. Pay-per-token mode is recommended for low-volume experimental workloads rather than production trading applications. It does not provide dedicated reserved capacity, cannot guarantee latency SLAs under sustained load, and is not designed for high-throughput production serving. Provisioned throughput configuration does not use a single fixed value. It exposes separate minimum and maximum bounds specifically to support auto-scaling between a guaranteed floor and a cost-controlled ceiling. Ready? Question 10. Look for the limiting phrase. A generative AI engineer at Cascade AI has been running a series of fine-tuning experiments using MLflow 3 to improve a customer churn prediction model. Each experiment run produces a logged model with captured metrics including F1 score, precision, recall, and execution traces. The team identifies the best candidate and registers it to Unity Catalog as a model version to begin the production approval process. Which statement correctly describes what happens to the performance data after this promotion? Select one. Review the answer choices on screen. The correct answer is option A. MLflow 3 makes logged model promotion seamless and lossless. When a logged model is promoted to Unity Catalog as a model version, all performance data captured during the development phase, including metrics, parameters, and execution traces, automatically becomes visible on the Unity Catalog model version page. This continuity is by design in MLflow 3, which treats logged models as first-class artifacts with full lineage that carries forward into the registry. There is no requirement to re-log performance data after promotion. The association between the experiment's logged model and the resulting model version is established automatically. Metrics are not siloed to the MLflow experiment view only. The UC model version page surfaces the same performance data to support governance and production approval workflows. Promoting to UC does not create a disconnected or empty entry. The link between the logged model and the model version preserves the full development history for auditability and compliance. Questions 6 through 10 reinforced the billion vector threshold, showed that inference tables have two distinct silent drop conditions, and confirmed that MLflow 3 promotion preserves metrics automatically without re-logging. Let us switch gears. Question 11. Let the constraints drive the choice. A generative AI engineer at Vanderbilt Research is building a RAG system over a large corpus of scientific papers. Early evaluations show that 512 token chunks produce precise keyword matches during retrieval, but the language model frequently lacks sufficient surrounding context to generate complete, accurate answers. The team wants to improve answer quality without sacrificing retrieval precision. Which chunking architecture should they adopt? Select one. Review the answer choices on screen. The correct answer is option D. Small chunks find, big chunks generate, 2 levels, 1 retrieval. Parent-child retrieval solves the tension between retrieval precision and generation context by maintaining 2 granularity levels. Small child chunks are indexed and searched to find precise matches, while the larger parent segments containing those chunks are passed to the language model to provide rich context for generation. This preserves the precision of 512 token retrieval while supplying the 2048 token context the model needs for complete answers. Switching entirely to 2048 token semantic chunks degrades retrieval precision because larger chunks are less focused and return more off-topic content per result. Increasing overlap to 50% at 512 tokens adds redundancy to adjacent chunks, but does not meaningfully expand the context available to the model at generation time. A single 1024 token fixed-size chunk trades away retrieval precision without fully solving the context depth problem, and the compromise satisfies neither requirement as well as the parent-child architecture. Let's slow down here. Parent-child retrieval is a core RAG pattern worth really understanding. Imagine a library with a precise card catalog and full chapter reading rooms. That's the retrieval versus context tension in RAG. Small chunks, say 512 tokens, nail keyword matching, focused and specific. But hand that tiny snippet to your language model and it lacks context for a full answer. Big chunks fix context but blur your search. Parent-child retrieval gives you both. Use 512 token child chunks for search precision. Then pass the 2048 token parent segment to the model for generation. That way you never trade one for the other. The exam rewards knowing you can decouple search granularity from generation context. Keep your focus here. Question 12. Map the scenario to the capability. A generative AI engineer at Crestview Media is building an automated sports broadcast highlight analyzer. The system must accept a short video clip and a thumbnail image together and generate a structured JSON description of the key action, player identifications, and game situation. The engineer wants to use a single foundation model API call that natively ingests both video and image modalities without any pre-processing pipeline. Which model should they use? Select one. Review the answer choices on screen. The correct answer is option C. Claude Sonnet 4 handles images but stops short of video. Gemini 2.5 Flash natively supports all 4 input modalities: text, image, video, and audio, through the Foundation Model API. This native video support is the decisive differentiator that allows a single model call to process both a thumbnail image and a video clip without any additional frame extraction or pre-processing pipeline. Claude Sonnet 4 supports text and image inputs within the Foundation Model API, but does not support video as a native input modality, making it incapable of directly ingesting video clips for highlight analysis. Llama 3.370b Instruct is a capable text model with a 128K context window well suited to language reasoning tasks, but it does not support video content natively and cannot process visual streams without external pre-processing. Code Llama 34b is purpose-built for generating and analyzing programming code across multiple languages and has no capability for interpreting images or video content of any kind. Alright, question 13. The obvious answer may be bait. A generative AI engineer at Fabricam is deploying an internal HR assistant through Databricks AI Gateway. Company policy requires that requests containing employee PII, including social security numbers and email addresses, must be blocked before reaching the language model, and responses containing hate speech must be blocked before reaching employees. Which 2 AI Gateway guardrail configurations should the engineer enable? Select 2. Review the answer choices on screen. The correct answers are option B and option D. PII and safety filters each guard a different traffic direction. PII blocking is the correct guardrail for the requirement that requests containing personally identifiable information such as SSNs and email addresses must not reach the language model. When PII blocking is enabled, AI Gateway detects PII in both the incoming request and the outgoing response, and blocks the message rather than forwarding or returning it. Safety filters address the second requirement by screening model responses for harmful content categories including hate speech, insults, sexual content, and violence before those responses reach the end user. Rate limiting controls how many queries a user or group can submit in a given window, and is designed to manage cost and prevent abuse, not to filter sensitive content. Traffic splitting is a deployment strategy for routing traffic percentages to different model versions, which has no bearing on content safety. Inference tables are a monitoring mechanism that logs endpoint traffic to a Unity catalog table for analysis. They do not intercept or block harmful content in transit. Alright, question 14. Follow the operational constraint. A generative AI engineer at Sandwell Ventures is launching an LLM-powered writing assistant. During an initial pilot, the service expects fewer than 50 requests per hour with unpredictable usage patterns. After a successful pilot, the team plans to scale to tens of thousands of daily active users with consistent traffic. Which deployment strategy should the engineer follow across both phases? Select one. Review the answer choices on screen. The correct answer is option A. Pilot on pay per token, graduate to provisioned at production scale. Pay per token Foundation Model API endpoints, are the correct choice for the pilot phase because they carry no capacity reservation, charge only for tokens consumed, and require minimal configuration, making them ideal for low-volume, unpredictable workloads. Once the service scales to tens of thousands of daily users with consistent traffic, provisioned throughput endpoints become the right choice. They allocate dedicated compute, provide latency and throughput guarantees under sustained high concurrency load, and reduce per-token cost at scale. Databricks explicitly recommends provisioned throughput for all production workloads. Provisioned throughput endpoints do not support a min_provisioned_ throughput of 0, they always reserve capacity, so idle costs cannot be eliminated through this parameter. Pay-per-token endpoints lack the performance guarantees needed for high concurrency production traffic. Serverless custom model endpoints introduce cold start delays and are not a standard path for serving foundation model APIs. Okay, question 15. Read this one twice. A generative AI engineer at Atlas Search is building a semantic document discovery system for a global publishing company with a corpus of 2.5 billion paragraph embeddings at 512 dimensions. After evaluating standard AI search endpoints, the team determines they cannot accommodate the full vector count. Which endpoint type should they select, and what trade-off must they accept? Select one. Review the answer choices on screen. The correct answer is option C. The trade-off is explicit. More scale means hundreds of ms more latency. Storage-optimized endpoints are specifically designed for very large-scale corpora exceeding 1 billion vectors. They provide 10 to 20 times faster indexing throughput compared to standard endpoints, and are the correct choice when the corpus size exceeds standard endpoint capacity. The engineering trade-off is an increase of approximately 250 milliseconds in query latency, which teams must factor into their latency budget. Standard endpoints support approximately 320 million vectors at 768 dimensions. Even distributing across 50 indexes cannot scale to 2.5 billion vectors without exceeding the 50 index per endpoint limit, and fan-out queries add operational complexity and latency. Direct access indexes accept caller-supplied embeddings, but do not remove the underlying vector count ceiling imposed by the endpoint type. The endpoint type, not the index type, determines capacity. There is no sharding or storage-optimized schema concept for delta sync indexes. Endpoint type and index type are independent configuration choices. Let's slow down here. This endpoint choice comes down to specific numbers worth memorizing. Imagine you work at a global publisher and need to search 2.5 billion paragraph chunks by meaning, not keyword. You pick Databricks AI Search, but there is a wall. Standard endpoints top out around 320 million vectors. Your corpus is almost 8 times that size. The storage-optimized endpoint handles over 1 billion vectors, and it indexes them 10 to 20 times faster than the standard type. The trade-off? Every query gets about 250 milliseconds of extra latency. For a live chat app, that might sting. For a document discovery tool, it's usually fine. The exam loves this number. 250 milliseconds is the answer they want, not just somewhat slower. Know the number, nail the question. Questions 11 through 15 covered the parent-child retrieval pattern for precision plus context, the AI gateway guardrails split between inbound PII and outbound safety, and the pilot to production deployment migration path. Okay, question 16. The condition is doing work. A generative AI engineer is using an inference table to monitor a model serving endpoint that processes requests from a document summarization pipeline. After reviewing the table, the engineer notices that certain large document requests, which the API confirmed were processed successfully with a 200 status code, are absent from the inference table. Smaller requests appear as expected. What is the most likely explanation? Select one. Review the answer choices on screen. The correct answer is option C. The temptation is to blame latency. This is a hard deletion rule. Inference tables do not log request or response payloads that exceed 10 MB, even when the underlying model endpoint processes the request successfully and returns a 200 status code. This is a hard platform limit on payload capture, not a function of processing time or sampling configuration. There is no execution time threshold that selectively excludes large document payloads from logging. The only size-based exclusion is the 10 MB cap. The approximately 1-hour data availability latency applies uniformly to all logged payloads and describes normal propagation time for records that are captured. It does not selectively delay large payloads or explain their complete absence. The sampling_fraction parameter is a static configuration value set by the engineer that applies uniformly across all request sizes and is not automatically adjusted by the platform based on payload size. Here we go. Question 17. The wording narrows the answer. A generative AI engineer at a biotech research firm is building a pipeline that generates summaries of genomic study reports. These reports frequently contain dense tables of statistical values, p-values, and numerical ratios that must be interpreted accurately within the summaries. The team wants to choose a foundation model API model that prioritizes faithful handling of these numerical structures. Which model characteristic should be the primary selection criterion? Select one. Review the answer choices on screen. The correct answer is option B. Numerical reasoning is a distinct model specialty, not just context. Faithfully summarizing reports that contain tables of statistical values, ratios, and p-values requires a model designed for numerical reasoning. A model optimized for numerical reasoning and summarization can interpret structured tabular content and produce accurate descriptions of its values. The largest context window helps ingest long documents, but does nothing to ensure numbers are handled correctly once they are ingested. A model trained primarily on open-domain conversational text is unlikely to reliably parse and summarize statistical tables without domain-specific tuning. Embedding models produce fixed-dimensional vector representations for retrieval and similarity tasks, and do not generate text output of any kind. Here we go. Question 18. Anchor on the exact workload. A generative AI engineer at Coastal Fintech has developed 2 prompt templates for a compliance document summarization assistant. Both produce competent-looking summaries, and independent single-output scoring returns nearly identical average scores for each template. The engineer needs an evaluation methodology that can reliably distinguish between the 2 templates and align with human preference judgments. Which approach should they use? Select one. Review the answer choices on screen. The correct answer is option C. Pairwise lets the judge see both outputs simultaneously. Pairwise comparison is purpose-built for directly contrasting 2 candidate outputs. By presenting the query and both responses to the judge simultaneously and asking it to select the better one, this methodology captures relative quality differences and produces judgments that align more closely with human preference than independent scoring does. Single output scoring evaluates each response in isolation, which introduces inter-run variance and score compression near the top of the scale. When 2 templates produce similarly strong responses, aggregate averages often fail to discriminate between them reliably, even with stricter rubrics. Retrieval groundedness measures whether a response is supported by retrieved context, and is a RAG faithfulness metric, not a mechanism for comparing prompt template quality. G-Evil with chain of thought is a single output technique in which the judge reasons step by step before assigning a score to one response. It is not designed for head-to-head comparison of 2 candidates and shares the same instability drawbacks as other pointwise scoring methods. Let's slow down on this one. Choosing the right evaluation method is a real exam trap. Imagine you're judging two figure skaters, but you watch them on separate days. Each scores 9.4. You can't say who won. Watch them back to back. Suddenly one is clearly cleaner on the landings. That's this problem exactly. When two templates produce strong summaries, scores compress at the top of the scale. One study found 86.7% of responses earned the maximum score, making the numbers useless for comparison. Pairwise comparison skips this. The judge sees both outputs at once and picks the better one. No ceiling, no variance between runs. GEval, a method that uses step-by-step reasoning before scoring, still evaluates one response at a time. That's still single output. It can't pick a winner directly. When template scores look tied, only pairwise can break the tie. Next up, question 19. The verb matters here. A generative AI engineer at Caldwell Diagnostics is deploying a clinical documentation assistant through an AI gateway endpoint. The compliance team requires that patient identifiers such as social security numbers, email addresses, and phone numbers never reach the underlying LLM. Requests containing these identifiers should still be processed, only the identifying values should be removed before the LLM receives them. Which guardrail configuration meets this requirement? Select one. Review the answer choices on screen. The correct answer is option B. Redact replaces the value. Block rejects the entire request. PII detection with redaction replaces identified personal information, including email addresses, social security numbers, and phone numbers, with placeholder tokens, allowing the request to continue processing through the LLM without exposing sensitive identifiers. This meets the compliance requirement to remove identifying values while still serving the clinical documentation request. Safety filters target content categories such as hate speech, insults, sexual content, and violence. They are not designed to detect or redact personal identifiers. PII detection with blocking rejects requests containing personal information entirely, which would make the assistant unusable for clinical documentation since patient notes inherently reference patient details, the opposite of the intended behavior. Rate limiting controls request frequency and has no capability to inspect, detect, or sanitize personal information within request payloads. This one trips people up. Never reach the LLM makes you want to pick blocking right away. Imagine a doctor types, patient John Doe, SSN 1, 2, 3, 4, 5, 6, 7, 8, 9, is being treated for. Your AI must still answer, but it cannot see that SSN. 3 phrases in this question tell you exactly which answer to pick. Never reach sounds like blocking, but should still be processed kills option D. Block the whole request and nothing gets processed. Then only the identifying values should be removed. Nails it. That's redaction. Redaction swaps 1, 2, 3, 4, 5, 6, 7, 8, 9 for SSN and sends the clean version to the model. The question rewards catching all 3 phrases together, not just the first one. Next up, question 20. Convert the story into selection criteria. A generative AI engineer at Ridgeway Capital is building a RAG application that must answer analyst questions from 2 data sources, a collection of PDF investment research reports, and a relational database of live portfolio holdings stored as structured tables. How should the engineer design the retrieval layer to handle both sources? Select one. Review the answer choices on screen. The correct answer is option B. SQL queries structured data. Semantic search retrieves unstructured documents. Structured relational data is most effectively accessed through SQL, which can filter, aggregate, and join portfolio rows precisely according to the query's specific requirements. Unstructured PDF content is best handled through semantic similarity search over a vector store. Using a single vector index for both sources forces embedding every row of a live portfolio table, which is impractical for freshness and loses the precision of SQL aggregation and filtering. Exporting structured tables as flat files sacrifices the ability to run targeted queries and introduces staleness. Feature serving is designed to expose pre-computed and continuously updated numeric or categorical feature values for model inference, not to perform semantic retrieval over document corpora. 3 takeaways from this session. First, storage-optimized AI search endpoints handle billion-plus vector corpora, but add hundreds of milliseconds of query latency second. Provisioned throughput requires both min and max parameters. Pay-per-token pilots graduate to provisioned at production scale. Third, inference tables silently drop records for HTTP error responses and payloads exceeding 10 MB. These questions reward specificity: the 5 GB artifact ceiling, the 1 billion vector threshold, the 10 MB inference table limit. Anchor those numbers, and the right answer will surface before you finish reading the options.